Hey, hello everyone, and welcome to From Zero to Useless to Hero, making runtime data useful in teams. We are Florian and Robert, and today we want to talk about a rather big project where we learned a lot about how to integrate modern observability tools. At first, we completely failed in making these tools appealing. But with time, we found interesting ways to make them accessible for a wide range of teams and stakeholders. So concretely, a few years back, Deutsche Telekom wanted to build its own voice assistant. And they wanted to do that to give their customers new ways to access and control products like TV, smart home, and telephony. As this was a greenfield project, DT wanted to build it with modern cloud-native architecture. And of course, that included structuring it into many smaller focused services that somehow work together to serve the user. And that made it very necessary for us to think about observability, or how to get a good understanding of the interactions between all those services and if they are still healthy and how their performance is going to look like. Now, here's something to give you an idea of the scale of this project. So we basically went from zero with a very, very small team and just a prototype to one international cooperation with Orange, with over 900 direct collaborators on the project, over 500 active Git repositories, and in the end, over 100 unique services that are somehow working in the back end to fulfill the user's requests. Now, note though that these are completely outdated numbers at this point. They're probably even bigger, but I don't know. So as you can see, that's a lot of stuff. And I will now hand over to Florian for a deep dive of how we tried to tame this monster backend.
So let's start at T0. The smart speaker was a greenfield project, so there was nothing to see for miles around. Everything is so clear. What a luck. Before we dig into the architecture on the next slide, I feel that this landscape is way more beautiful as the architecture. So what's necessary for building the backend software system of the smart speaker? First, we need some voice services to process the voice commands. So for example, apply natural language understanding or to do audio speech recognition. We also need services to manage our devices, the so-called device services. They can roll out new software versions or send push notifications to the smart speaker. In front of our two service groups, we have two gateways, one for handling the admin access and one for handling the API access. Everything runs within a Kubernetes cluster, so we have all the cloud native things that are necessary to operate such a system in a successful manner. The nodes of our cluster run in some cloud, and the provider also provides storage technologies that we use, and in front of our Kubernetes cluster, we have a proxy that terminates the SSL connection. What's missing, but it's not part of the backend software system, are the skills. A skill provides a functionality to the end user. So for example, if I request as an end user the weather forecast, the backend software system first applies audio speech recognition and then natural language understanding and extracts that information and sends them to the skill, and the skill uses that information to request the weather forecast. The skill knows where he gets his information about the weather, and then sends it back to the backend software system, and the backend software system sends it to the skill, to the smart speaker. I lied, as I said, there was nothing to see for miles around. Of course, there are systems that we need to integrate. So the Deutsche Telekom has an identity management system that we need to integrate, or we use the content delivery network to ship firmware versions to the clients. So the smart speaker is one client. The second client is a mobile application that is also used by the end users to configure the smart speaker or to see the conversations a user made, or some more features that the end users can use. So this is just the high-level view. If we dig into the details, so for example, we also need to ensure that the application is secure. So we have tokens and two-factor authentication and certificates where it is necessary, or we have network policies within our Kubernetes cluster. So, and there are more if we dig deeper. But I feel that even at this level, this is quite a complex architecture. And a complex architecture, in my opinion, leads to a complex software system. And the more things a software system is composed of, the more things needed to be watched, because the more things can fail. And in terms of an error, you need to know what thing failed. And this also leads to a complex analysis. So, but we are not the first one that implements such a cloud-native software system, and we're not the first one that need to analyze such a system. So there is a standard toolchain for the cloud-native applications if you are using open source tools. So and we also use that standard toolchain, which consists of Prometheus and Grafana for metric data. So this is numeric data collected from time to time. So it's sampling based. We use Prometheus to instrument and to collect and to store the metrics. And we use Grafana to build dashboards and to explore the time series. For textual event-based data, such as the application log, we use Florian to collect them and to transport them to the Elastic Stack. So they are stored in Elasticsearch, and we use Kibana to search the logs and to explore the logs. Spans, also event-based data. So span is the unit of work within a trace. So we collect spans with Spring Cloud Sluice, send them to the Zipkin server that stores the spans in Elasticsearch, and for exploration we use the Zipkin UI. The project started 4 years ago, and since then we did some changes to that initial toolchain. So we replaced Zipkin with Jaeger. We now use Humio instead of the Elastic Stack, and we moved our own instances of Prometheus and Grafana to Grafana Cloud. So we simply moved to managed services where it was possible for us. So in the next step, after installing the toolchain and that the toolchain works and everything can be used, the next step was to focus on how we can combine and integrate these different kinds of data. So how to combine metrics with traces, how to combine textual event-based data with spans and traces. So, and because we're enterprisey, we came up with a solution that is called standardize all the things. So now let me introduce you to our very own generic standard runtime data smart hub service data model. So the name is just for the presentation, but I used this data model to explain what we achieved, and what we thought that might be a really good approach. So in the middle, there is the service. A service has a context. And around the service, we have different kinds of data. So we have log messages, we have traces, we have metrics. And we tried to spread this context, and the context might be a user or a single request or something. So the context is not really hard defined. It can be defined by some values. We try to spread this context around the whole data model. So, for example, we wrote a logging concept, and we ensured that every log message has parts of that context. So, for example, the tenant is part of the context, so the tenant must be part of every log message, or the user ID, or the span or trace ID. We did quite the same for tracing. So we give tracing best practices that state that every trace must at least have a tag called tenant, and the value is the tenant, or the user ID, and all the other things. So we also defined metrics that describe how well an application is covered by spans. So there are no blind spots within a trace. We also standardized incoming and outgoing request metrics. So we use the RED method that stands for request rate, error rate, and duration. And every incoming and outgoing metric has a predefined text. So there is also a part of the context. So we also have the tenant information. And we did quite the same for database metrics. So every call to a database is monitored based on the repository and the tenant. We standardized liveness and readiness checks and ensure that every readiness and liveness check exposes metrics about its state. So the developer can implement its very own specific liveness or readiness check, but we ensure that we have a uniform surface of every check. And we also defined that every response, if successful or not, must contain the trace ID. So that we have in every case, we have a single piece of information that is part of the context that allows us to dig into the whole data model and to combine and find the information in the different sources. So that was the idea. And we enforced them within the project, and the developers implemented it. And then we see that metrics are coming in, metrics have the right tags, traces have the right tags, log messages are in the format that we defined, and everything was great. And we noted that it really helps us to understand our software system in case of an error. So this was a really, really good thing for us. And we thought, well, done, this solved all our problems, and the others will love it. How could we be so wrong? And the reason is the team. If you look at our team that implements that whole project, the team can be described with a single word, colorful. So our team is heterogeneous, consists of different experts having different roles in mixed teams. So for example, we have production management, we have testers, we have data scientists, we have first level supports, we have operation heroes, and we have developers for different things and parts of the application. So we are simply a colorful bunch of people with having different skill sets. And if you look at Robert and myself, we are monochrome. So we built a monochrome solution that fits for us. And that was the time where our solution was useless for the team. Not for us. For us, it was really helpful, but for a team, it was useless. So we are the experts. We know how to use the tools. and the data and to combine them. And for the others, it was simply the hurdle was too high to use that solution. And finally, no one except us uses this solution. So it was not helpful. So we looked outside of our monochrome box and we came up with that image from Alan Cooper from the book Interaction Design. And simply says that everyone that starts using a product starts as a beginner. And after some time, if you're using the tool more and more, you will become an intermediate user. Most of the users of a product are intermediate users. And if you use the tool even more, maybe sometime you will be an expert. You know all the features and all the things. If we look at our solution that we build an expert solution. We know the tool chain, we know the tools, we know the data, we know the tags, we know how everything is interconnected. And it is not that users are too stupid to get experts, they simply do not have the time. So, and that's what we need to address. We need to try to move our solution from being an expert solution to an intermediate solution. And how we achieve this to move our toolchain to an intermediate level, this will tell you, Robert, in the next few slides.
Okay, so we had this expert solution, right? And we had to make it a little less intimidating. But how actually? Our solution provided a lot of utility at this point. So we realized that something else must be missing. And it was this obscure thing called usability. And we were like, come on, we are backend guys. Like usability, I can't even spell that. By the way, I really can't spell it. So we tried to learn about this dark magic and we found this description and we liked it a lot. So something has high usability when it's easy to learn, tasks can be executed very efficiently, it's easy to recall how something is done, the error handling and messages are useful, and the user feels satisfied using it. Yeah, okay, makes sense, but where should we actually start with that? So we figured that probably we should start with the first contact, improving the first contact with the tooling. So we thought it should be really straightforward for everyone to find the stuff that they are interested in. So in the next slides, I will show you some examples of how we did that. And I hope it gives you maybe some inspiration on what you could do in your next projects. One super simple thing that you can do is deep linking. So this is a Grafana dashboard that shows errors for our continuous test suite. And I can click this little info button on the left, and this opens the tooltip, and there I can find deep links to other observability tools that relate to this graph. So in this case, I can immediately jump to the test reports of the test suite and find out why a test failed. And I can also directly access the system logs so that I see what has happened behind the scenes in the backend. So by just adding a few links, we took out the complete mental overhead of, okay, when I switch to a different UI, for example, for logging, what query do I have to make to actually find this stuff? Now it's super easy and it's actually a very low effort way to bring your tools together. So you just start in one tool and you have links to click through to jump to other tools. Now, here's another example. Each of our environments has a landing page for internal users where after you logged in, you find shortcuts to our observability tools for that particular environment. Now, again, taking out the guesswork, I don't need to know which domain prefix and so on I need to get the logs from a certain environment. I just need to log in once, and then I can click here to get to the right service. Now, in addition, what you see here is that we have some quick actions. So if I want to look up a certain trace, I can just put in the trace ID here and click search, and this takes me to the tool, either to the tracing tool or logging. And that relieves me of, again, the burden of knowing how do I actually query that stuff in the tool. And we have the same, as you can see here on the bottom, for user IDs, because that's a very common use case. For example, to look up error logs for a test user. Now, before I go on here, I already see some people basically face palming here, like, whoa, dude, enterprise discovered hyperlinks. Yeah, okay, get it. Let me step up my game in the next slides, okay? Here's a support use case where we integrate our observability tools, and I like that very much. So imagine the customer calls the hotline because he has an issue with our device. And in our case, the special thing is that the support actually wields the superpower to activate tracing for that user in production. And then the experts can actually look at data because it has been collected. And of course, in the spirit of GDPR, the user has to be asked for permission. But for the support in the end, it's super easy to activate tracing because it's simply a button in their support UI. They don't have to know any other technical specifics about it. As a follow-up, such a bug ticket might be created. And by simply adding the relevant trace ID to the ticket, now everybody can easily get some context for this issue. And with that change, the QA manager now is the happiest person in the world, because the days of issue closed, not clear enough, cannot reproduce are completely over, right? So this is another very cool example. We have an in-house tool for config management and software promotion. So if you look at it, now it's pretty ordinary, right? Has a minimalistic UI. I can promote my service from one stage to the other. I can release to production on Friday, the usual stuff, basically. Except, what's this small status label there? Well, that's actually a very tiny, tiny window into the runtime metrics of this service. It also changes color when the developer messed up. And you can click it to get more information, which looks like this. So here I get a dedicated view for this application with more top-level data. For example, what the Docker image tag is, or how often the app restarted. Again, in the middle, you can also find links to our observability tools. So I can immediately jump to its traces and logs. For a developer who uses this page basically every day, it's now super easy to jump to the other tools. Now, of course, it's definitely a much bigger effort than the previous example, but you can also see that you can achieve a higher level of clarity because you can only show the most relevant information and leave out all the noise and expert data. So over time, this tool became very popular and grew a lot through further feature requests. Finally, I guess this is the crown jewel of our achievements in that space. It's a pretty sophisticated example. So as we were building this assistant, we needed a simple and accessible way to test it out that would also work for less tech-savvy people. So the team came up with the idea that we could build a bot for our internal Mattermost chat that you see on the right here. This is another great way to understand the system, because you can basically learn by example through watching other people sending commands to the assistant. And of course, we again found a cool way to integrate our observability. So in this example, you can see that something went wrong, and therefore in the answer of the assistant, deep links are added. And with those deep links, I can immediately again jump to the traces and logs and start debugging the issue. And so with those functionalities, the chatbot became so popular that it was very easy to use, because it was very easy to use. And therefore it was very appealing for basically everybody in the project. Now, this is the mandatory slide telling you that, of course, everything got better and we did exactly the right thing. But jokes aside, indeed, we saw some positive cultural changes. So definitely the visibility of the system and the trust in the system increased, because just there's on-demand access to runtime data. The developers got more aware of their own systems and how they behaved on runtime. The communication definitely got a boost, because you were able to pass around these links and IDs as an entry point for debugging. The error culture improved as well, because with the increased visibility, it allowed people to also look beyond their own services and better work together on a solution in a better way. And finally, all these improvements made it easier for teams to really take ownership of their services. And that's exactly what you want if you need to scale out a project with many teams like we had to. Yeah, and so with the work we put into those additional usability improvements, that helped us to get from zero a little bit closer to hero observability. And basically we made that happen by listening to our internal customers, our developers, and for example, QA, operations, and other stakeholders. And because we decided to make a substantial investment into shaping those tools so that it's really easy to get started and easy to jump between those different data sources. Of course, some things caught us off guard, and we learned a few things on the way, and I would like to share them with you as well. So one thing is, you have to recognize that modern observability may challenge your team structure, because developers are basically the main people to instrument your application. It's not some distant operations team that puts some instrumentation on top. And this works, of course, best when you are having self-sufficient teams that run and build the software on their own, so that the requirements and the know-how and the awareness about what metrics are important for the service are ideally located in the same team. You should definitely instrument early and instrument everything. This gives you very early value when you start out with it, and it helps growing and understanding why this additional work of instrumenting stuff is actually worthwhile. Otherwise, if you don't do that, you might have a hard time later, because you have to do a large batch before it is useful, a large batch of integration work. After you have some basic visualization, immediately focus on your users. That means your other teams, stakeholders, other roles that might benefit from the additional insights. So once you do that, you can build observability that is actually used by a lot of stakeholders, and this just makes it more valuable. You should also plan ahead for the reliability of your observability tools, because what we realized is that once the teams use those tools on a day-to-day basis, any service interruption will basically block their work, and you will have an outcry and you have to fix it. So very quickly there comes a point where those tools need to be as reliable and available as other developer services. For example, your Git infrastructure, your GitLab, or your build runners, and so on. So to go a little bit deeper into the last point, you maybe remember the slide from earlier from Florian, and we've seen that we actually switched our observability services a couple of times. And one of the main reasons that we had to do this was that we needed to run them reliably, and that it was equally important for development and production. Now, when we unpack that, basically means each of these services needs to be scaled, operated, and updated. And you need to figure this out 3 times because you have to do it for metrics, logging, and tracing. And in addition, ideally, you already want some baseline linking, some baseline correlation between the data out of the box. And to top that off, you also like to integrate common cloud services that you already use, common managed services, for example, your serverless functions or your managed databases, because that helps you to get a single consistent view. So instead of doing it the hard way like we did, use our lazy pro tip. Don't build and operate the basics if you don't have to. Get a managed service and spend the time you have saved to build really cool stuff, like the chatbot that we showed. So that's all fine, but how could this look like in a managed environment? I'm just going to randomly pick a cloud here. Let's say AWS. So if you were running your backend on AWS, you could gather your logs and metrics with CloudWatch and traces with X-Ray. And as these are managed services, these operations become very easy and you can benefit from the deep integration with other AWS services. So for example, with X-Ray, you can not only capture requests from your applications, but it also helps you, for example, to capture interactions with DynamoDB. Now, you can correlate the stuff between CloudWatch and X-Ray with AWS Service Lens. So that helps you to also already being able to jump between data sources out of the box. And that means less manual integration work for you. And finally, there's also Prometheus and OpenTelemetry support. So that means your applications can use these open source interfaces to set their metrics and traces. So we are going to wrap up here with our recipe for observability. So first step, select your tool chain, ideally choose a managed solution, and then standardize your metrics, logs, and traces. Then link and combine your data as much as possible so it's easy to get started and to jump between tools. And finally, put good entry points into the everyday tools and processes of your teams. At this point, the teams will love you for the improvements, and you might like them a little more too, because they are asking less stupid, I mean uninformed, questions about your apps or their apps. So we hope that you enjoyed this presentation. Please feel free to reach out to us if you have any other questions or feedback. Thanks a lot.